Plotting numbers on the number line. Page 23 of your formula book, which you are allowed to use in your state exams, has sets and logic symbols that will help you with this section of the chapter. So one of the symbols that you will see in the next few slides is this symbol. It looks like the euro symbol, and it means is an element of. You will also see this symbol here, which is a capital N that stands for natural numbers, which are positive whole numbers. So we can see the set of natural numbers starts at 1, 2, 3, 4, 5, 6, and very importantly, ... to indicate it goes on forever. So 0 is not a natural number. That's important. Then we see the capital letter Z, which stands for integers. And integers are positive and negative whole numbers. So we can see ... minus 3, minus 2, minus 1, 0, 1, 2, 3, ... So the dots indicate that they go on forever in both directions. So the important thing to note here is that natural numbers and integers are whole numbers. They are not fractions, they are not decimals. The next symbol that you will see in this chapter is the capital R, which stands for real numbers. And real numbers are all the numbers on the number line. So they're positive, negative, fractions, decimals, and so on. So all the numbers on the number line. And a tip for answering questions involving inequalities that we will see in a few minutes. If you are asked to draw x values that are elements of the natural number set or the integer number set, you can draw noses. So think of the N and the Z go together to create the word nose. Now imagine that it's spelled with a Z. So N-O-Z-E-S, noses. So you can draw noses on the number line for N or Z. And if you see a capital R, you draw a road and a steering wheel. So when you see a capital R, you want to think of road and a steering wheel. So I'll go into that more in a few minutes. So in your study of numbers so far, you will have dealt with natural numbers and integers. These numbers are described again below and illustrated on the number line. Natural numbers. Natural numbers are the counting numbers starting at 1. They are denoted by the capital letter N. So N is equal to 1, 2, 3, 4, 5, ... The arrow indicates that the dots continue indefinitely. So we see we have dots on 1, 2, 3, 4, 5 and an arrow to the right. So this is what I mean by noses. You want to think of like a big red nose, like Rudolph the Red-Nosed Reindeer. Number 2, integers. Integers are whole numbers which may be positive or negative. They are denoted by the capital letter Z. The integers are illustrated here on the number line. So Z is equal to ... minus 3, minus 2, minus 1, 0, 1, 2, 3, ... So we see noses or big red dots on all of the numbers negative and positive. And we have an arrow at the left and an arrow at the right to indicate that they go on forever in both directions. 3, real numbers. Real numbers describe all the numbers on the number line. These numbers include natural numbers, integers, fractions, decimals, and numbers such as square root of 5, square root of 7, pi, ... So all the numbers on the number line. Since every number on the number line is a real number, we say that the real numbers fill the number line. For this reason, real numbers are represented on the number line by a heavy or a bold line as shown below. The capital R is used to denote the set of real numbers. So we can see we have a big, thick, bold line that goes along the whole number line, and the arrows go in both directions to indicate that all the numbers on the number line are real numbers. Inequalities. The speed limit for cars driving in a city is generally 60 kilometers per hour. This could be written as speed less than or equal to 60, or S less than or equal to 60. This means that S, the speed, could be 60 kilometers per hour. It could be 58 kilometers per hour. It could be 56 kilometers per hour. It could be 40 kilometers per hour, ... The statement S is less than or equal to 60 is an example of an inequality. X plus 3 equals 7 is an example of an equation, since one side is equal to the other. However, x plus 3 is greater than 7 is an example of an inequality, since one side is not equal to the other side. Here are the 4 inequality signs we will use. So this one here represents is greater than. This one represents is less than. And a handy way to remember which is that this looks like a capital L, a squished capital L. This one represents is greater than or equal to. And the last one here represents is less than or equal to. We will now use these inequality signs to show how different numbers can be shown on the number line. Natural numbers. The inequality x is greater or equal to 4, comma, x is an element of the natural number set, so xen stands for x is an element of the natural number set, means that x may be any whole number greater than or equal to 4, i.e. that is 4, 5, 6, 7, ... These are represented on the number line below. So I'm going to draw out the number line step by step. So we start with a line. And then we need to draw in our little lines, and they must be equal distance apart. So very important that they are equal distance apart. And then I'm going to draw in the numbers. So since I'm told that x is greater or equal to 4, I know I'm going to need to include 4, 5, 6 at least on my number line, and a few numbers before that as well, because you don't just start at that exact number. So we'll have a few numbers that are less than 4. So I have 0, 1, 2, 3, 4, 5, 6, and 7. So I want to draw the inequality x is greater or equal to 4. And x is an element of the natural number set. So since I'm drawing natural numbers, positive whole numbers, I'm going to draw noses. So I'm going to draw dots, big red dots, on the numbers that fit in with this inequality. So x is greater or equal to 4. So I'll start off with a big red nose, a big red dot at 4, because this is telling me 4 is included. And then I need one at 5 and 6 and 7. And very, very important, I need to draw in my arrow to indicate that this inequality goes on forever. So the natural numbers that are greater or equal to 4 are 4, 5, 6, 7, 8, 9, 10, 11, ... on and on forever. So that's why we draw in the arrow. Notice that the arrow goes the same direction as the inequality sign. That will always be the case if there's any arrows involved. So x is greater or equal to 4, comma, xen. So this part here before the comma means x is greater or equal to 4. And this part means x is an element of the natural number set. So remember, draw noses for natural numbers. The inequality sign and the arrow point the same direction. So it's pointing to the right, the inequality sign, and the arrow is pointing to the right. So that will always be the case. If the inequality sign was pointing to the left, then we would draw our arrow on the left. If we rewrote this as x is greater than 4, what would change on the number line? We would rub out this dot or this nose. So if we have x is greater than 4, we take out the dot at 4. Number 2, integers. The inequality x is greater than minus 2, comma, xez, so this means x is an element of the integer set, represents all the integers greater than minus 2, i.e. minus 1, 0, 1, 2, 3, ... These are represented on the number line below. So we start off again with our line, and then we draw in all the little lines, making sure that they are equal distance apart. Then we have our numbers. So I'm going from minus 1 up as far as 5. And I'm going to put my first dot or my first nose at minus 1 because I'm told that x is greater than minus 2. So I'm not putting a dot or a nose at minus 2. I'm putting it at the next number, the next bigger number. And then I'm going to put a nose at 0, 1, 2, 3, 4, 5, and very, very important, my arrow. So again, notice that the arrow and the inequality sign are pointing to the right. They both point the same direction. So x is greater than -2, comma, xez. So this means x is greater than -2. And this means x is an element of the integer set. And again, we draw noses for integers, just like we draw noses for natural numbers. So why is there no nose on -2? And that's because the sign is greater than and not greater or equal to. So that's very, very important. There's no nose at -2 because it's just a greater than symbol. It's not greater than or equal to. So if this changed to greater or equal to, what would change on the number line? We would draw in a nose at -2. So if this changes to greater or equal to, we draw in a nose at -2. Real numbers. The inequality x is greater or equal to 3, comma xer, so this means x is an element of the real number set, is the set of all real numbers greater than or equal to 3. The inequality x is greater or equal to 3 is represented on the number line as follows. So we have our line and our little lines with equal gaps between them. We have our numbers. I'm going from -1 to 6. And then we're going to draw a big, what I'm going to call steering wheel at 3. And I'm colouring it in. You'll see in another example where we have it empty. Then I'm going to do a big, solid, thick line to the right of it. And my arrow. So again, notice the arrow goes the same direction as the inequality symbol. They're both going to the right. So x is greater or equal to 3, comma, xer means x is greater or equal to 3, and x is an element of the real number set. So we draw a steering wheel. So at the number 3, we have what I'm going to call a steering wheel and a road for real numbers, a solid line, a thick solid line. What if the inequality sign was greater than instead, so without the equals part? Then we would draw an empty steering wheel and everything else would be the same. So if it just said greater than, it's an empty steering wheel. The inequality x is less than -2, where x is an element of the real number set, is shown below. The empty circle at -2 is used to show that -2 is not included. So there's my numbers. I'm going from -5 to 2. I draw in my empty steering wheel at -2. I draw my big thick line to the left and my arrow. Again, notice the arrow and the inequality symbol are facing the same way. In this example, they're both facing the left. So x is less than -2, comma, xer means x is less than -2, where x is an element of the real number set. Real line intervals. If x is greater or equal to -3 and x is less than 2 and x is an element of the real number set, an interval of values is obtained starting at x is equal to -3 and finishing at x is equal to 2, but not including 2. On a number line, this is represented as follows. So I have my numbers. I'm going to draw a full steering wheel at -3, an empty steering wheel at 2, and I join them together with a thick line. So x is greater or equal to -3 and x is less than 2. We actually put these together and this becomes our inequality. So x is greater than or equal to -3 but less than 2. So to summarize, n is our natural numbers, z is integers, or is real numbers. We draw noses for n or z. We draw a steering wheel and a road for or. And if there's an arrow, it goes the same direction as the inequality symbol.